Aha. I don't prepare meals on my lap. It's been too long since I've used this program, man. So rusty. I'm slow. I'm trying to figure it out again. I used to be a really good 3D modeler. But it's coming back to me. It's like riding a bike, right, guys? This is not CAD. This is Maya. You can build actual movies on this. This is an advanced 3D modeling and rendering solution.
Here we have a cube with the manipulator tool in the center of the object. And if we go to rotate this object, it will rotate around that pivot in the center. But say if we need to rotate this object on this lower edge of the cube, we would need to move the pivot of this object. In order to do this, we would need to use the Move Pivot tool. To initiate the Move Pivot tool, on PC, press the Insert key, and on Mac, press the Home key. When you do, you can see the
What the heck, Dimebag? I thought you guys would be happy to see me doing something besides video editing. I'm actually doing something, and you still give me Resident Sleeper? What more do you want from me? For crying out loud, I'm actually doing something interesting right now. I'm not muted. Oh man. It's gonna work. I know it, man. It's gonna freaking work. Can I just make them all like... Huh. There we go. There. I'm preparing a 3D print by adding holes in it so that it won't warp. If you don't know what 3D print warping is, you should look it up because it's pretty crazy and pretty terrifying. And it's been ruining all of my prints for my customer, which showed me that's why they wanted me to print for them. So basically, people go hire out a 3D printing service if they can't do their own prints. Most likely this person has a 3D printer and they were failing. So they hand it off to me as the pro, and I'm failing too. So it's up to me to figure out the solution or else I'm screwed. I'm supposed to be the guy with the answers. And the messed up thing is, these guys could have been 3D printing for years, and I just started. And I'm having to figure out these advanced problems that they gave up on, and they handed it off to me. It sucks, because I'm just trying to make some money on the side 3D printing. I didn't think I'm going to have to only deal with the hardest 3D prints that other people couldn't 3D print. That's what it comes down to. As a 3D printing service, you're the guy that does the impossible prints. Everyone else is going to do all their own prints at this point. So, not only do you have to be able to print fast, but you have to be able to print stuff that nobody else can print. You have to have either a better machine or better techniques. I'm using like a little known hack that very few people even need, which is to create a bunch of punched out holes. Each of these cylinders I'm putting in here is going to be a hole I'm punching out in the model. This is the model, and we're going to make holes in it where all those cylinders are. And that way when the print prints, each layer will have relief of the stresses that that layer wants to create to rip the print into a warped shape. Each layer is like the string of a bow and arrow, and it wants to rip up the layer below it. And with each layer, those strings get tauter and tauter. They're like rubber bands, and they'll rip up the bottom and tear it all up. Here is actually a failed print of this exact part. You can see here it's supposed to be perfectly flat on the bottom, and that ain't flat at all. So, and then it also tore up right here. You can see delamination. You can see a hole actually through it, and it just tore itself to pieces during the cooling process during the print. It's all messed up. So, and it's not a matter of, oh, and then here's another print I did. It tore itself to pieces on the edges. You can see this edge is supposed to be flat like the top, but you can see it's got this lip on the bottom that just came up. Looks like the bottom of a boat. It's all curved. And it just got all tore up. It looks horrible. So we're putting holes in everything now so that the print will be rock solid and way faster. It'll spend less time in the printer because these prints are literally like 12-hour prints. It takes 12 hours to find out you're screwed and the print failed because you got to print really slow on a cheap printer. I print at 40 millimeters per second on average, as far as like the main print speed. Some layers are even slower than that, but some are faster. Like the travel speed's faster and stuff like that. But the overall print speed's 40 millimeters per second, which is very slow. So now only the areas that don't have the circle are going to be printed. So this is going to print, this is going to print, and these shorter sections horizontally don't pack the amount of, when they shrink, they're going to shrink and pull in on the curves of the circle. They're going to pull these this way to the left. And the circle can handle those forces, and it won't be transferring those forces to the lower layers. So if you pull right here, that's just going to cause the circle to widen. It won't affect these layers, so it won't rip them up. The problem happens when higher layers want to rip up lower layers and make them curve upward, like a bow and arrow, or like a bow and arrow bow. If you're taking the string and trying to shorten it, it bows it more. Well, we're just cutting that string into segments so it can't have that powerful force. The longer the string is, the more it will try to warp it, the more it will bow the lower layers. So we're cutting the strings up into segments. Now, I want to save these circles and 3D print them separate as plugs, and we can glue them into the holes. But because I'm running way behind on my 3D print, those plugs would take forever to print as well, days. So what I'm going to do is just put some masking tape over the hole on the back side and pour ABS slurry sludge into it, almost like pouring cement into a plastic bucket. And that will cure, creating a solid fill of ABS plastic. Now I'm not going to fill it all at once because I fear that could cause the whole model to get gooey. So I'm going to, and it might not, it's just a theory, but I'm just going to pour it in maybe a couple millimeters deep at a time. Just keep filling it in until I build it up. Kind of like repairing drywall with drywall mud. It's just a matter of building it up until it's flush, and then overlap it, and then feather sand it. Or it's like filling in a dent on a car for bodywork. So I'm going to fill in all the circles as if there were dents on a car with Bondo, and then I'm going to sand it. And I'm not using Bondo, I'm using ABS slurry sludge, which is acetone and ABS mixed to create a thick sludge, like peanut butter consistency. So that will be my spackle. And I'll fill all these holes manually, which will get rid of a lot of my scrap ABS from failed prints. And it will save a ton of printing time because I'm basically, everywhere you see a circle is less printer filament your 3D printer has to use, which means your 3D printer doesn't have so much stuff to print anymore. Now you also have to take into account the architectural strength. So if you remove in your mind all these circles and just leave what's remaining, it has to be architecturally strong. So for example, you can't put this circle right here because then this will be a weakness. That can break too easily. If you were to stand with your foot on top of this top ledge, you don't want that force to transfer through here, and through here, and snap this right here at the weakest point. So you're going to want to make sure there's plenty of thickness between these circles and never a gap about wider than that, which, I mean, you never want a gap between circles to be more than approximately like 2.5 centimeters. If it's more than 2.5 centimeters in width, so like if I move this one over here, that would be enough to create a crack or delamination and possibly even warp the bottom right here, is this long string of layers, layer after layer, pulls upward on these lower layers that will cool faster. These will peel upward. So you don't want to have too much gap here, otherwise you're running into the same problem that this whole thing's supposed to solve. So you want good structure architecturally. Think of it like a bridge, like supports of a bridge, and this is the bridge. You want the supports to be solid. Even though I know we're going to fill these with solid plastic after the fact, you still want it to be structurally strong on its own, because maybe the filled circles won't be as strong or attach as well, and I think that the actual printed job should be fairly strong without filling in the circles. The circles filling in will definitely strengthen it up even more though. But we don't want to introduce too much structural weakness because we want the final print to be strong. I'm assessing this corner here. It is pretty close to the edge right here. But I think that the strength of this wall will carry over into this so that it doesn't actually matter how close that is to the edge. So that's a non-issue. But this does matter. But this is still like one pillar. Even though it makes a 90-degree turn, it's still one solid pillar. So it's okay if that's close to the edge. So yeah, I'm looking at this not aesthetically, but architecturally from an engineering point of view, like as if I were designing a bridge. And these are all going to be air holes until I fill them in. So now I'm just copying this over to the other side, because it'll be the same on both sides. That looks good. I want to move these back a little bit. So what's cool is you can actually print out each of these plugs as well. So like if your printer gets done with the job in time and you're filling in holes manually, you can have the printer print out these holes and you can just super glue them into place. You'll need to print the holes slightly smaller, or the plug slightly smaller than the holes so that they'll slide in easily and allow the glue to do the rest. Yeah. So that's an option to print out all these holes. Okay. So that's looking really good to me. We got it perfected. I think that's gonna work. Do you normally print with triangles? Yeah, all STL files are triangles. STL files are the types of files you import into your slicer software, and then your slicer software converts it into G-code. Your G-code goes to the printer. So we're creating an OBJ in Maya, which we're going to export as an STL. I mean, well, first you take your STL from the customer and you bring it into MeshLab and you convert it into an OBJ and you export it as an OBJ. You import the OBJ into Maya, you add the holes in Maya, and then you export from Maya as an STL. You import the STL into your slicer software which then converts the STL into G code. Then you transfer the G code to your 3D printer. So that's the workflow, and that was really hard to even say now after having slept 7 hours. It was very difficult to conceptualize all this complicated stuff while I was half asleep last night trying to do this. What's up, Nickly? And I'm not a butt face. No, it won't be cheaper to mail. It's going to be just as heavy because I am filling in the holes. You can't ship it to the customer with these holes. In fact, you have to hide these holes. The customer can't know that these holes are here. He didn't want that. He just wanted it to come out like this. Which I had to do a lot of work to get it almost perfect like this. And it's still not quite good enough. It's almost there. Because this one did warp, but I carved it and adjusted it. But now it's not perfect. But anyways, yeah, they didn't want this print to have these giant holes in it. So you have to fill in the holes, overlap the fill, sand it smooth, butterfly it in, just like filling in dents in a car, and then paint over it with a thin veneer of ABS juice in order to create a crystal clear, smooth finish. Not a clear finish, a crystal smooth finish that has no indicators that you ever printed with holes in it. Now, you can avoid all of this by getting a 3D printer enclosure that keeps the whole print heated and prevents the warping from happening to begin with. But that enclosure is putting a lot of heat onto all of your servo motors, onto your heat bed, onto your model, onto everything. And that can cause all kinds of new problems electrically and cause your servo motors to burn out prematurely. Or not your servo motors, your stepper motors. So that might help to prevent warping, but it might, in the end, do more damage than it does good. I'm not baiting gays. Okay, so what's next? I have to think here. I want to save. Alright, I just saved. I'm still getting the hang of the camera controls. This is pan, this is twist, zoom. I'm getting the hang of it now. What we need to do, it's not for the robot. This is a 3D printed model. I'm preparing the 3D print model for my 3D printer for a customer. I offer 3D printing as a service to make money with my 3D printer when I'm not using it on my robot. Okay, so I need to actually remove the geometry everywhere these cylinders go through, but I want to store a copy of the cylinders, a virgin copy, first. Okay, I just copy pasted it with Control C, Control V. I'm selecting them all, and I'm going to move them out of the way, upward, just to store them, because we're going to be deleting these shapes, leaving just the holes. I want to store them in case we have time to 3D print these as separate prints, and then use these 3D printed holes to fill in these holes in the model. Or, no, we'll use these 3D printed plugs to fill in all the holes left in the model. Of course, we'll need to make the plugs less tall if we were to do that, which we can do later. And incidentally, printing rounded things like this does not cause warping. But printing large flat walls does cause warping. So these plugs will be easy to 3D print without any issues, I believe. Well, that might not be true. It might still cause issues, but I mean, we can put little holes inside these plugs too, and then make even smaller ones. Like, do this again with little holes in the bigger circles that we put up here, and then leave holes here, and then put plugs into those as well. So it's like plugception. All right. So now we want to combine, I believe. Let's start out with just these two. I'm going to go to Mesh, Combine. Okay. Now they're one object. I'm going to go to Face Mode. Select the face, delete. Select the face, delete. Select, delete, select, delete, select, delete, select, delete. Oh. Interesting. It's like we have mesh errors or something. Uh, that's not working out. It was supposed to treat this as a separate face. It didn't do anything I thought it would. Vertex. It didn't create vertices where I thought it would. Let me see, I want to place the vertices right here. How do you place one? Okay. Mesh, booleans, difference. Ah! Uh... Okay. Oh! Mesh, booleans, difference. No. Mesh, booleans, difference. Ooh. Has to do with what order you select them in. Oh my gosh. Thank you so much, Big Bangus. See, it's smart, I think, to main body first, then the cylinder. Okay. Thank you so much, Funky Bee. That helped me a lot. Main body, then cylinder, mesh, booleans, difference. Oh my gosh. It feels good. This feels really good. Main body, then cylinder. Mesh, booleans, difference. Mesh. booleans difference. Let me see if I can do this faster. Main body, then cylinder. Cylinder, 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 cylinder. Mesh, booleans, difference. Uh-oh. Mesh, booleans. That confused the software. It was like, what? Main body, then cylinder. Mesh, booleans, difference. Uh-oh. What the heck? We got weird things now. What's that mean? Can you clean or something the geometry? Let's see. Like what I want to do is add line or like add a line from here to here, here to here, here to here. Because it's unclean. It's supposed to be like triangles or squares, right? Edit mesh. Oh, cut faces tool. Mesh. Cleanup, maybe. No, triangulate. Mesh, triangulate. There we go. Now everything's a triangle. Everything's a happy little triangle. Alright. Mesh, booleans, difference. 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 Alright, I want to triangulate it again before it starts erroring out. Triangulate. Mesh, booleans, difference. Mesh, booleans, difference. Mesh, booleans, difference. Man, you really saved me, Funky Beat. I appreciate that so much. Because I was like, I'm just so lost here. I would have done something that probably would have worked, and it probably would have taken me forever. Okay. Mesh, booleans, difference. So I have to assume that you do 3D modeling, or you work with this stuff. Like, I used to be able to do 3D modeling, animation, everything, but that was literally like over a decade ago. That was back when Autodesk was 3D Studio Max, and that was Maya's main competitor. Maya was a totally different software program. That's when I used to do this stuff. Now it's Autodesk Maya. They converged into one. There's probably other competitors now. Mesh, triangulate. Okay. Wow, it's a lot harder for my computer to render this thing now. Just trying to figure out all this geometry. Okay. So this is how our print is going to come out. And we got all the plugs up here. And we can print these plugs separate later if we want to fill in these gaps. But for now, it's just about getting this print going. I believe the print will be way faster with all these gaps in it. But most importantly, it's going to be guaranteed not to warp like it was doing. All these provide stress relief points for stress created when the print is cooling. squares are industry standard for most things. I knew that, like for video games, when I actually did video game character modeling for a zombie shooter video game, and everything had to be um, squares. Actually, yeah, squares was also considered like quality workmanship for any 3D modeler who was proud of their models. If you had one rectangle, I mean one triangle, you were like, oh crap, how do I turn this into a square? And you wanted to have nice, clean contour lines and all of your lines looking nice, and everything forming beautiful squares. And that's how modeling was done. And I imagine it's still the same way. I guess a lot of video games will turn it into triangles anyways, but normally you want everything squares to begin with. But I noticed that STL files are all triangulated anyways, so okay, so we can now export this model as an STL somehow. File, export selection to desktop. We don't want it as Maya binary. We want it as STL-DCE, I guess. I don't know what DCE stands for. 5x bracket thing, we're gonna call it. And we'll export it. Error, line 0, could not save bracket thing.stl. Okay, we'll export it then as an OBJ. Export selection. I know it can do OBJ. Surely it can do OBJ. No. Son of a. Oh my gosh, dude. I want to export as OBJ so I can open it up in MeshLab and then export it as STL since I'm not able to export as a STL. Wait a minute. Maya 2013. How to export STL in Maya 2013. Okay. Windows. Settings and preferences. Plugin manager. Does it say anything about STL? OBJ export bundle. Crap. obj export .mll. Okay, so it was different than what he had.
I'm not sure why they don't.
His said obj export .bundle. Oh, it's just a different file extension. His is .bundle, mine's .ml. It's still obj export.
Make sure your OBJ export bundle is set up, or this will not work whatsoever. Alright, so we're going to go ahead and select, make sure it's combined, delete history, increase transformation, and we're going to export either all pipe.
Okay, now it's file. Okay, close. File. Export selection. obj export. Okay, we have an obj now. I'm going to open up the obj in Mesh Lab.
Yahoo search did STL.
Okay. So 5x bracket obj file, which we just created. Material definition is missing. Okay. Beautiful. Looks pretty cool in Mesh Lab. Okay. I'm not uneducated. What's up, Franco? How's it going, Mailbox? Alright, guys. File. Export mesh as STL. Save. Okay. Now we come into Cura, which is our slicing software. Okay. And we can actually drag and drop this. I think it's just trying to like process what I just did. Yeah, it's not responding. It's just taking a minute. Yeah, it's loading it though. Okay, so it's loading it. Oh, there it is. Oh, snaps. Oh, now it's slicing. Let's make sure. That's why I kept the original STL, which I got from the customer. I'm going to make sure that they're the exact same size before I mess with it. It keeps saying not responding because it keeps trying to recalculate everything. They're identical, man. Look at that. Okay. So there we have it. That's the difference. We did it. We frickin' did it, guys. And so it's going to print like this instead of like this. And it's not going to have any warping because it's got all these stress relief holes. And it's going to be a way faster print. So 5 hours and 50-minute print. If we get rid of this one, how long? If it were the same print time, it'd be 2 hours and 50 minutes. It's 3 hours and 16 minutes. Okay, it's a longer print. What the heck? It takes longer to print this. Why? Why the frick would it take longer? Ah, because it supports. It's trying to support those inner circles, which we don't want. So I'm going to disable the supports. They don't need supports there. Watch this. It's going to take way less, I think. It's reslicing. What does this bracket do? I don't know. It's a model from a customer. So let me explain again. I believe most people that know about 3D printing, they know what it does, they know what it's for, own a 3D printer. It costs 150 bucks for a kit. Why not just buy one? So the only people that pay a 3D printing service to do their print are people that know about 3D printing, meaning they have a 3D printer and they just didn't have time to print it, or they're running into problems. So a lot of times your prints are going to be problem prints. You have to know how to print the most difficult to print objects, objects that are known to cause problems. In this case, an ABS print of a long, tall sheet of wall. It's guaranteed to warp. Well, put a bunch of holes in it, it's not going to warp. Yeah, I'm giving them... No, I'm not going to give them a hole-filled mess because I'm going to print out all the plugs for these holes. If I don't print them, then I'm going to put a sheet of masking tape on the back and pour in molten ABS to fill the holes. Kind of like filling dents on a car with Bondo. Structurally, it will be the same. You won't even be able to see them. I'm going to sand it all to a fine surface finish at the end. You won't even see a seam. It'll be seamless. They'll never know I did it. Meanwhile, the print will be perfect. Alright, it's a 2-hour print. Which is kind of surprising. I'm going to go over all my settings, and I'm doing it, YOLO. I thought it was going to be a way faster print than that. For crying out loud. Oh my gosh. Alright guys, I discovered that since the print wasn't really faster with all these holes in it, I should just stick with maybe Well, way fewer holes, I guess? Maybe? I tell you what, I could do smaller holes. I don't know if that'd matter that much. Okay, my wife said just the holes in the corners. Hmm. Alright, I think I have to start over here, so let me just bring that up. Wait. File? No. Hide that. Go back. File. Import. All files. Desktop. Import. No. File. Import. Okay. Uh, so the idea my wife proposed, which I feel, is worth a shot, is just to put the circles in these corners. Maybe these two as well. Okay. Um, Wind, no, mesh, booleans, difference. Mesh, booleans, difference. Mesh, booleans, difference. Mesh, booleans, difference. That's worth a shot, right? What's up, Night and Slimy? No, I was up most of the night dealing with these 3D printing disasters. And I still have customer orders to fill, and I'm way behind. I'm in total panic mode. I might be keeping it together in your guys' eyes, but you have to realize. File, export selection, OBJ export, 5x bracket, minimal circles. What do you guys think? Why don't you as chat help me decide? Do I just print this one with minimal circles, only 4 total, as stress relief points for the 3D print? Or do I go straight to the big boy with millions of circles? I think both. This one will guaranteed print successfully. This one is a big unknown. I don't know if that will be enough. I suppose there's a good chance it would be enough. Yeah, you know what? I am going to go ahead and just do this one. So minimal circles. All right, we exported it as OBJ. Now we can import it into MeshLab. Shave off almost an hour by having all those extra circles. Hell with it, we'll leave them. Although it'd be interesting to see if this would print. I'll do this on the next print, but I like that it's going to save time with more circles. I'm willing to save the time, but the more circles takes me more time in post-processing, but I'm looking to save any printer time I can, so that's a trade I'm willing to take. I'm wondering why it's so daggone slow. So we put the stress holes on both corners, but there's still such a long strip of plastic wall, and this is only about this big so far, that it managed to pull up the corners despite the stress hole. You got to break up the plastic strip even more than what I did. So I'm going with the full-blown stress relief holes everywhere route. I'm not going to play around anymore. I wanted to see if the minimalistic just one hole would be plenty and I could just use that for all models from now on. But no, that's not how it played out. And so from now on, I'm going with the Swiss cheese method where I just put holes everywhere. And that's that. That's final. That's how I'm going to do 3D printing from now on. That's set. That's all I needed to see. I just needed to verify, because my wife mentioned, hey, you know what, maybe one hole would be enough. I wanted to see if one hole in each corner would be enough, and it was not. That's a fact. I verified it, and so now I know I'm going to put Swiss cheese holes everywhere. And I won't be guilty about it thinking, oh, I'm doing something that's overkill. No. It's not overkill. I verified that it's not overkill. Alright guys, so this is the difference between a model with no holes in it. This is supposed to be totally flat on the bottom. Look how warped that is. And then here's how it's supposed to look. They look nothing alike. That's sad. This is the same exact model. Look how clean the holy one is. That's why we add the holes. Because everything gets screwed up if you don't. So that's a proof. And that's with the same printer, same everything. So I'm definitely going to be putting Swiss cheese holes in all of my stuff from now on.
Oh my gosh, man! Guys, this works, man. Look at that. Why? Why? For what? Whoa! What? What? Is that faster?
Yeah.
No, I do it. Alright, it's really fun. It's gonna work, dude. Okay, can you just set it down somewhere? Alright.